talk about the shapes of polynomials. So to start out, we're just going to draw a few graphs of what polynomials kind of look like. We know how an x polynomial looks like. That's just like a line. Like maybe it looks like that, or maybe it's like sloping down. I'm just going to leave this line. An x squared, that's a parabola. Maybe it's a smiling parabola or a frowning parabola. I'm just going to draw a smiling one because that's happy. X to the third power, well, those functions can look like that. X to the fourth power, these functions can look like that. X to the fifth power, these functions can look like something like this. You kind of get that. So some things to notice. What's going on here is that when you have I'm just going to write 1 because this is really x to the first. X is just x to the first. When you have an odd exponent here, then the function doesn't like double back on itself totally. Here it's for x to the first, one side goes up, the other side goes down. For x to the third, one side goes up, the other side goes down. For x to the fifth, one side goes up, the other side goes down. Whereas for x squared and x to the fourth, things with even power, both go up. Both go up. Or we could have both going. We could also have both going down. We could just as easily have a parabola like this, or a squiggly thingy like this. But the key thing to notice here is that odd power, the sides go in different directions. One goes up, the other goes down. But in even power, the two sides go in the same direction. Either both go up or both go down. Another thing to notice here, not just the direction of the sides, but also the amount of curves in the graph. X to the first, this doesn't have any curves, it's just a straight line. So I'm going to put 0 curves. Or should I say 0 humps? Or, well, no, curves is probably. Maybe I should say turnarounds? Is that a better word? Because x squared turns around once. It turns around right here at the vertex, or it's going this way and it turns around right here at the vertex. X cubed can turn around at 2 spots here. So, yeah, let's call them turnarounds, not curves. So 1 turnaround, 2 turnarounds. X to the fourth, that can have 3 turn rounds. Because 1, 2, 3, x to the fifth, that can have 4 turnarounds. So you kind of see a pattern here. The other pattern is like x to the n has n minus 1 turnarounds, or is capable of having n minus 1 turnarounds. Because you could have like an x cubed that doesn't actually turn around. You could have something that goes like this. But let's not worry about that just yet. Right now, this is the main intuition. Yeah, so x to the n has n minus 1 turnarounds. To get the amount of turnarounds that a function can possibly have, and that a polynomial can possibly have, you just need to look at its degree, and you need to take 1 away from its degree. So let's just do a little bit of practice in the next video.